Okay, honored chemistry fans, let's talk about significant figures, of course, which in your current chemistry class is me, the most significant figure. But significant figures, also known as significant digits, are really the application of using your data and your measurements to get accurate answers. Um, it's a bit confusing at first for students because in all reality, you've never been asked to examine or use the digits in a number in an application sense. And math mind, generally in math, it's, hey, round to, you know, a tenth of a tenth or a hundredth or whatever. Significant digits or significant figures is the method you use to take the data that you're collecting and the math that you use to get to an appropriate answer. Now, one thing to understand, and that's the slide here, all measurements aren't accurate. The precision of the measuring device is, and it's just because you can't, how do I say inaccurate? Think about it this way, and this is what I experience with the majority of the students who start this. You do calculations on your calculator. And in your head, the more numbers past the decimal point that I show, the more accurate the number is. And that is far from the truth. The number of digits that you show in your answer must reflect the measuring device, the least accurate measuring device that you use. Okay. Remember one thing, your calculator is a tool. It did not do the experiment. It did not collect the data. It did not observe the data. It does not know how to round the data. It just does math. And if it's like my calculator, I can set it to show me anywhere from 1 to 9 digits on the screen. Okay. So all measurements just are inaccurate because you can't measure to infinity and beyond. So it's how precise is your measuring device? Certainly there's human error. Certainly there's faulty technique. And again, when using calculators, we must determine the correct number of digits in our answer. The calculators are tools. They don't know the correct answer. Okay? Your measurements and the math that goes with them need to convey precision. And what I'm going to tell you right now, which you may not believe, and students want to argue with me, but if you are not using the correct significant digits, your answer can actually increase in error. Okay. There is one digit of uncertainty. Okay. But the significant figures, the sig figs, tell us how precise and how accurate the measurement is. Okay. Now, here's the example. You have 3 rulers measuring a hunk of wood. Now, as you can see, as I go from A to C, my measured length, and that's what a significant digit is, an actual measured number, an actual measured part of whatever you're measuring, plus one guess. What's the one guess? Well, this is 0.6. How do I know it's 0.6? I can look at this ruler, this 1 meter ruler, and estimate that's a little over half. I can call it 0.6. That's as accurate as I can get. One significant digit. Now, I just put in the centimeter markings, and now I can go and say, okay, it's 0.6, and that's about 1. So here's my one actual measured, and here's my guess. This, on the first one, is just my guess because there's nothing measured. There's no line to tell me anything. Now I put in the millimeter markings, And now I can go, well, that's 0.6. It's not quite 0.61. It's a little less. I'll call that 0.07. But I can get three significant digits because the 0.6 and the 0, absolutely. And then the 7 is my estimate. So whether you're using a ruler, whether you're using a balance for mass, whether you're using a graduated cylinder for volume, whatever you're using, when you finish all the math, you must round your answer to match whatever the least accurate tool you were using with, to match those digits that you got off of that tool. Okay. Now let's just think of the density of our penny lab. We did the mass on the triple beam balance. That would have given you probably 4, maybe a little more, probably 4 significant digits, because you could read that accurately. But your graduated cylinder for volume really was only marked with 10, 20, 30, 40, and a couple things in between. So that one is probably is going to be 3 significant digits. So really, your density is most likely, and we could look at your data separately, but most likely, we'll talk about this with the analysis, going to have to be rounded to just 3 digits, possibly even 2. I'm not at school looking at the graduated cylinders. Okay. Again, the significant digits that need to be included in the answer are all the digits you know and one last guess. That one last guess is the last space between the final 2 lines. So between the 60 and 70 here, between the 60 and 61 centimeters there. You're allowed that one estimate where you roughly guess where it is between the last 2 lines that are in the measurement. Okay. Now, the key to looking at a number and figuring out how many significant digits it has in it. Say you're just doing this on a piece of paper, you're not using, or you've collected your data and you're sitting down with it, you're not using your scale or whatever, or you're checking someone else's lab, you're doing a peer review of someone's lab, so you didn't do the lab, but you're looking at their data. The easy one, the easy answer is anything that is a 1 through 9 is a significant digit. It was measured. If you come up with a 1, 2, 3, 4, 5, or 6, it was a significant digit, as highlighted in red here. So anything that's not a 0. The key confusing part for students, and the thing we have to work with, are zeros. Because you can measure a 0, or a 0 can be a placeholder to hold the value of the number. Okay. So let's break down zeros. If the 0 is at the end of a number, and the number has a decimal point anywhere in it, those are significant digits. So these, along with, so this 12.740, 1, 2, 3, 4, 5 significant digits. The 0.04200, 1, 2, 3, sorry, let me do this again. 1, starting at the 4, 2, 3, 4, 5. The first 2 zeros don't count here, as we're going to see in an upcoming slide, because they're placeholders to tell you the value is below 1. But you don't measure anything until you hit an actual number. 0.0 didn't measure anything. It didn't move the scale. The 4 is when you first got to a number. The 0 sandwich, any zeros between 2 other significant digits are always significant. Okay, so these all count. So in all of these numbers, everything here counts because you've got all your non-zero numbers and the zeros are stuck in between. It doesn't matter how many zeros there are. And it certainly doesn't matter if there's a decimal or not. Decimal's irrelevant here. Okay. Where a decimal is relevant is here. There must be a decimal somewhere in a number for these at the end to count and not be placeholders holding the value of the number. Okay. Zeros used only for placeholders to keep the magnitude of the number not significant. These are all zeros that begin a number and all at the end when there is no decimal point anywhere in the number. So we already addressed this bottom one. All these zeros are wonderful, but they're just placeholders to tell you how far below 1 that number is. Okay. So anything you don't start counting significant digits, counting left to right on the number, until you hit an actual number. Now, what about the 100 here? Now, this is an answer that could have been rounded to 100, but only needed one significant digit. It still needs to keep the value that it's 100. Okay. Maybe it was 99.9, which rounds to 100, but you can only have one significant digit, so that's 100. But there's no decimal there, so these are placeholder zeros. That's the key. Know your placeholder zeros. Placeholder zeros are always in the front of a number. Placeholder zeros are at the end of a number if there is no decimal anywhere in the number. Okay. And always put a 0 in front of a decimal point. So these are all, but these are all placeholders. This only has 1, 2, 3 significant digits. This has 2. This has 3. So let's look at a few examples here. And I won't do them all, but you can think of it. 400 has 1 significant digit. These zeros are placeholder because there's no decimal anywhere in here. Where this one, 200, is 1, 2, 3, 4 significant digits. The 2 always counts. And these zeros count because they're at the end and there is a decimal in the number somewhere. 1 significant digit. The zeros up front are placeholders. 3 significant digits, all non-zero numbers. 3 significant digits. The 5 and the 3, absolutely. The 0 at the end because there is a decimal in the number. But the zeros out front, never. They're placeholders to tell you the value. That's the idea. Okay. All right. Scientific notation. The only numbers in the base number are the significant digits. So there's 1. There's 2. There's 3. There's 3. Okay. Now, couple of math rules for rounding your answers with significant digits. I will tell you add and subtract. We just don't do it that often. Almost everything we do, because it's algebra based, is multiplying and dividing. If you add or subtract some numbers in your math, the answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. So here's our example. 12.11, 18.0, 1.013, blah, 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 blah. Okay. If I add this all up, the answer is 71.875 centimeters. All right. I round that to 71.9. Okay. Because I can only have 1 digit past the decimal. That's the least number in the problem at the 18.0. So here's my 1, 2, 3 digits, and then the 7 tells me to round up. Okay. And the least number can be no significant digit. You know, if it doesn't have a decimal, if it's a whole number without a decimal, that can be 0 places after the decimal. So that's adding and subtracting. If you multiply or divide, which is what we do most of the time, 2 or more numbers, then the answer is rounded to the number is in the least. So which number has the fewest? Let's give you another example. 5.15 and 2.3. That has 3 significant digits. That has 2. I just do the math, and that's a key component. You don't worry about rounding to significant digits till you've got the answer. Don't try and think of it ahead of time. Just get the answer, then round the answer. Because 2.3 is the least amount of significant digits, I have to take 11.845 and I have to round it to 12. so that it has two significant digits. 1 and 1, the 8 tells me to kick it up to 12. All right. Again, most people understand the concept. It's getting used to the concept and doing the math with the concept, running the answer properly, and it's the zeros that throw everybody off. Okay. So remember your placeholders. Zeros in the front never count as a significant digit. It was never measured. Zeros at the end never count if you are missing a decimal in the problem. So I'll leave you a few calculations you can try here, but I'll give you the background. This has 1, 2, 3 significant digits. This has 4. When you multiply, you're going to round your answer from left to right to 3 significant digits. This number with the 0 sandwich has 1, 2, 3, 4 significant digits. This has 2. So after you divide, your answer has to be rounded to 2 digits. That's the idea. And I'll leave these. You can pause the video and kind of do some practice with this. And then that's one of those things you can always ask me about, you know, did I do this correctly? All right, I'll look at the third one for you. You're adding these. So this has 2 numbers past the decimal, 1 and none. You're going to add them up and you're not going to have any numbers after the decimal. Now, let's talk about scientific notation. There's a couple errors, and again, I see this as math isn't telling you wrong, but they're not telling you correctly. They've shown you the process, but there's one glaring error that I find with students coming into chemistry and science. Scientific notation, of course, is the way that we take very large numbers and shrink them down to manageable size, or very small numbers and shrink them to something that you can use. Okay. Here's, and I already mentioned in the blue, only the significant digits in an answer are included in the base number. Okay. The key is this second bullet point where kids make errors. Numbers are written as a product of a number between 1 and 10 times whatever, however you shifted the decimal, however many jumps that was for the exponent in the times 10. So 215 goes to, I moved the decimal, the assumed decimal here, boom, boom, to 2.15, and that was 2 jumps. So it's 2.15 times 10 to the second, because I moved 2 times to the left. Where the error comes in is a student will just move at one spot and call it 21.5 times 10 to the first and say that's the same thing. No, it's not. You can only have one number left of the decimal in scientific notation. Okay? That's a simple error that I see students do. So again, as examples here, 1500, there is only 2 significant figures here because these zeros are placeholders. Why are they placeholders? There is no decimal in this number. So 1, 2, 3 jumps, 1.5 times 10 to the third. Here, every one of these are significant. These count. Why? Because you got a decimal in the problem. So again, I'm moving it 2 times to get so that it's 3.4200, and I moved it twice, so it's times 10 to the second. Here we're going the other direction, so we're going to have a negative exponent. These zeros or placeholders don't count. What about the 0 at the end? It certainly does count as a significant digit because it's at the end, and there's the decimal. So I move 1, 2, 3 to the right. 3.450 is my base number, and I move 3 times to the right, so it's times 10 to the negative 3. Okay. There will be times when your answer must be in scientific notation to get the proper amount of significant figures. There will be a time when you get bent that if you round it, then all the placeholder zeros at the end won't give you enough significant figures, but if you put the decimal in, you have too many significant figures. And so I gave you this example here. The density of pine is generally 0.50 grams per centimeter cubed. What is the mass of an 800 centimeter cube piece of pine? Right? So mass is density times volume. The 8.50 has two significant figures, the 5 and the 0 at the end because of the decimal. This one's a placeholder. The 800 decimal is three significant figures because the 8 and these two zeros count because of that decimal. So when I multiply that answer, the answer is 400. But I need two significant figures. Right now, without the decimal, I have 1. But if I put in the decimal, I have 3. That's the conundrum. So to properly write the answer with only two significant figures to match the 0.50, I need to write it as 4.0 times 10 to the second. Okay? And again, I've got a few of these, just as I have with your in your unit outline. I have a few of these. I will kind of leave them to you. What is the density of an object with a mass of 3050 and a volume of 750.00? These are things you can ask me for after you do them. Distance learners and others. I will point out this has three significant figures at the 3050. The first three numbers, the 3 and the 5, the 0 sandwich, but that 0 does not count because there's no decimal in the problem, in the number. This has 1, 2, 3, 4, 5. The two non-zeros, of course, count, and all these zeros at the end count because, again, there's a decimal. Okay. So this is going to be rounded to three significant digits. Okay. If you ran for 26.2 miles, how many kilometers was this? Your answer is going to have three significant digits. All right. That's the idea. Okay. So that is our video on significant digits. I believe your book does a great job in that little section of the chapter 3 in also explaining it. We don't have a specific page in your packet that says how many here and there, but now for both your density lab and your unit outline, you can go look at your answers, round them, because I didn't tell you had to before, round them properly. That is, I'm going to guess if you are checking your density unit outline problems against the key and wondering why my answer was one way or yours was another, and again, knowing that all things are slightly inaccurate, it would be how many digits are in your answer and how did you round them. And so that's where we get the work out of our unit outline as you go back and look at your answers, look at the least number of digits in the problem and round that way. Absolutely great stuff to ask questions for either in class or Zoom or in the building or setting up a office hour time. Anyhow, have a great day. We will talk to you later.